the agenda for today's webinar, we're going to start with testing 101, and we're going to show you some tips and tricks, what and when to test, and how to test these gauges and equipment. On to replacing, when to replace, what universal solutions we offer, what custom solutions we offer, and our support team that can help you get to those, the end of that road where you need to be. And then we'll briefly talk on upgrade opportunities. If you're going in for a replacement, what options you have to expand the capabilities of your monitoring of your transformer. And then we'll follow up with Q&A live right here. You can submit your questions through the chat box on the webinar. So let's dive right into it here. So what and when to test? So most transformer protection equipment can be quickly tested to ensure functionality in the field. And it's not always a full functionality test, but as far as switches for alarming and control functions, those can easily be tested on the majority of the equipment that you will find on your transformer. And the reason you want to do this is because faulty equipment can result in much larger and more costly issues down the line. For example, an undetected sudden pressurizing your transformer can result in a catastrophic failure. Inoperable switches on, say, your thermometer for cooling, and you don't have your cooling stages coming on, that can lead to much bigger potential issues. So here at Qualitrol, we recommend to test all protection equipment that is either tied back to an alarm or control circuit, and the trip. You can include trip in there too. So anything that you use to gather data and information from your transformer, we recommend to test that at some point. A lot of these, it's really not beneficial to set it and forget it, At some point during, scheduled maintenance or any schedule that you may have, it would be wise to test a lot of this equipment. And testing schedules vary between, utility to utility, location of that utility, NERC requirements, other IEEE requirements, and whatever preventative maintenance or maintenance schedule that you may be on, it would be a good time to include some of these tests into that schedule. So today, we'll be covering quick and easy field testing for our liquid level gauges, temperature gauges, pressure relief devices, sudden pressure relays, and sealant relays. So we'll start out here with our liquid level gauges, and flow gauges can also be tied into this group because they function on the same basic design. So the liquid level gauge is used for a few reasons on the transformer. It's obviously to detect a low oil level, which can, if it gets low enough, it can result in catastrophic failure. And it's also used for filling the transformer and things of that nature. Most of the time, the switch contacts are at the low setting on the liquid level gauge to indicate a low oil level. And we have some videos here for testing to kind of simulate it, or to show you how easy it really is. So testing a liquid level gauge or a flow gauge, all you really need to do is remove the case from the flange. So most of the time there will be 4 set screws on the side of the case. So what you see here is the case portion of the liquid level gauge. They're magnetically coupled, so magnetically driven. So all you need to do is remove the front case, and then use any magnet, and you can place that right on the center back of the drive shaft of the liquid level gauge, and you can actually move the pointer and actuate the switches. So here you can see there's the first low switch and there's the second low switch. And all I'm doing is twisting that magnet on the back. And that gives a good simulation of the actual drive mechanism moving inside the tank. And then the same on the 3.5-inch liquid level gauges as well. So one thing to note with the liquid level gauges is that the part of the gauge that takes the most environmental wear and that's out and exposed is the case. So the flange is covered up by the case on the outside of the tank, and then the rest of the flange is internal, which is most of the time submerged in oil. So doing a full functionality test on the flange itself most of the time it isn't accessible or necessary. And for how simple it is to test the liquid level gauge, most of the time this is a great way to see if those contacts are still working and they're functioning at the levels where you think they are and where you want them to be. So we can move on to our remote temperature gauges. This first test here on the left only applies to remote temperature gauges that we offer. Our smaller direct mount, you cannot do the same type of test. I just want to make that clear up front. It could cause some damage on direct mount, but with remote mount, this test is fine here. So remote temperature gauges are used for obviously oil temperature and winding temperature, top oil and winding temperature. And these can also be used for alarms or cooling stages, turning on your cooling fans, pumps, your whole cooling system. So you really want those switches to be working and know that they're working. So testing our remote temperature gauge. So this here on the left is our 104 and TR6000 family. It's also nearly as simple, if not simpler, than the liquid level gauge. All it requires is to remove the front bezel, remove the front lens, and then you can actually push the pointer up the dial to actuate each switch. And this won't cause any harm to the gauge at all, as long as you don't push it down from where the temperature range is currently sitting. So right in this video, we're right at about 25 C. So I'm just letting that glide down the dial range because it is spring loaded and it'll return back to that original place. But it's no problem to push it up the dial range and actuate those switches. And that's a real quick and easy way to test that all those switches are functioning and that they're actually going off at the desired temperature. Another quick and easy field test, which you can see on the right here, to test actual functionality of the thermometer itself, is just an ice bath test. And what this does is, once you put it in the ice bath, it's going to zero out. You want it to zero out. And if it doesn't, that can lead to other issues, like say there's a leak in the capillary, because this is a high pressure capillary system. There could be a leak. The preload, there could be an issue with that on the gauge. So you really want that to zero out, and that's a good quick way to do a functionality test. You could pull that probe out of the well, put it in a cup of ice water, and watch the gauge go down to zero. So these are two easy field tests that can be done on the 104 or TR6000 that we offer. This ice bath test can also be done on direct mount bimetal thermometers. Pushing the pointer cannot be done on those. So let's move on to our pressure relief devices. So here specifically, we're going to be talking about our large pressure relief device and our extra pressure relief device, which are LPRD, XPRD, sometimes the 208 or 213. So full functionality testing of the pressure relief device is very difficult in the field. You would need to have a tank that you could pressurize to the relief pressure to simulate a blow-off of the pressure relief device. But testing the switch is very simple on both of these. And the reason you want to test the switch, because that's typically the most common failure point on these. You're not going to have excessive wear on the springs or seals internally on the pressure relief device. The switch is what is out in the environment. It takes the brunt of the damage and wear and tear. So it's best to test those on a regular basis too. So we can see here video of the LPRD testing. The majority of our LPRD switches have this test lever here. So on the right, you can see the test lever, and on the left, you can see the reset lever. So what you're going to want to do is pull the test lever until you hear the switch click into place, and you can see it actuating up the top here. And then you can just reset it with the reset lever. And if your LPRD switch does not have a test lever or a reset lever, this same test can be done with a screwdriver. And underneath here, you'll be able to see the little cam gear that rests on the relief plate of the pressure relief device. And you can actuate that and then reset it with a screwdriver and do the same test. Testing our XPRD, is just as easy. So here are a couple of pictures of an XPRD. This is the top of the XPRD, and you can see the switch on the right side here. So in the normal state, the switch plunger is in this little recess on the indicator of the XPRD. And to test the XPRD, all you need to do is pull the indicator directly up. Be careful not to bend it, and pull it directly up, and that will actuate the switch. And that'll simulate this XPRD actuating and pushing this indicator up. So those are two quick field ways to test our pressure relief devices that we offer, both the LPRD and the XPRD. Moving on to our sudden pressure relay, this would be our Qualitrol 900 or 910 RPRR, typically called. And for field testing of these, this is a full functionality field test. It tests the function of the RPRR itself and the switch function. And to do this, we have a field test kit, which is our Kit 013. It's a portable field test kit that can be used to simulate an actual sudden pressure rise in the transformer tank. So this video here is a quick little snip out of a full-length video we actually have on our website. So what this test kit does is you will hook it up to the vent port on the rapid pressurized relay, and you will simulate a sudden pressure rise in the tank by applying pressure to the top of the two chambers in the rapid pressurized relay. So they're separated by a bellows system. So if you increase pressure on the top of the system, it will equal out, and it will be back in a normal state. So what we do with the kit is that we apply pressure on the top, let the bellows level out and go back to a normal state, and then we quickly relieve the pressure from the top, which will simulate a sudden pressure on the bottom, driving the bellows into the switch and actuating that switch. So you can see that here in the video. So just to reiterate a little bit, so you're applying pressure on top of the bellows system, waiting for that to level out, and then you're relieving that pressure quickly on top, which simulates a sudden pressure on the bottom or in the tank. And this can all be done with our field test kit. And with increasing regulations, we actually have, there's actually a NERC requirement that requires the testing of sudden pressure relays, mechanical sudden pressure relays every 6 years, which this falls into that category. And our field test kit makes it really easy to do so. And last but not least, we're going to look at the seal-in relay that we offer. Seal-in relay is designed to take in a momentary switch contact and seal that signal in for alarming or trip function. So these are typically paired with our rapid pressurized relays because those are a momentary action, a momentary switch action. When the sudden pressure rises, it actuates that switch, and then the RPRR will settle back down, or the pressure will be relieved through some other means. And then you want to keep that alarm or trip signal because that was a serious event that occurred. And that's what this seal-in relay comes in handy for. And we often get questions on how to test these and make sure that they're functioning properly in the field. And that is also incredibly easy, similar to the past products that we've looked at. So with the 909-300, which is the most current model we offer, the 909-200 is the previous model, which is now obsolete. Testing the 909-300 is very simple. What you're going to do is lift the signal from the input, which is pins 1, 2, and 3 on the 909-300. So say you have an RPRR hooked up to it, you want to disconnect that, and all you do is jump pins 1 and 3. And this will simulate a contact closing on those terminals, and which will give you your trip function. And this same simple test can be done on the 909-200, but instead of jumping terminals 1 and 3, you want to jump pins 1 and 12. And you don't want to mix those up between the two models, so be sure to check which model you have before performing this test. So once you've done your quick and easy field test, if you find any failures, we'll move on to what you can do to replace those. If it's an older unit, how we can help, and what options you have there. So equipment can be replaced on a proactive schedule or a scheduled cycle, or as failures are detected through testing. And the lifespan of a piece of equipment it varies greatly between environment, location, outside, inside. Some of these can last up to 50 years. Some of them can fail in 20. It all depends on the environment that it's in. If it's in a real dry, no ice, no rain, no snow, they could last a very long time. So determining equipment failure can come through testing, which we just went through, a physically damaged unit, completely inoperable. So say you go up to a temperature gauge and that it's just buried at 0 degrees and you know that the transformer is above 0 degrees. There's a good failure indication. And then if you do, say you do the ice bath test on a thermometer and it doesn't zero out, you can consider that incorrect indication. And if it's close, it could be calibrated. And if it's not, then there could be a bigger issue with the unit. And that could be any gauge, not just a Qualitrol gauge. It could be any old GE gauge like we have here, or old liquid level gauge. If there's any issues with contacts, anything like that. So we recommend to replace it when any of the above issues are found, and especially if it's hooked into an alarm circuit or trip circuit or a control circuit. And when it comes to critical equipment, such as a sudden pressure relay that trips your transformer, it's sometimes beneficial to replace those proactively. So, for example, you're on site with a scheduled 6-year maintenance program, and you notice that sudden pressure relay is 40 years old, and it's still working, but it could be a good idea to replace that because a failure of that magnitude could be much more expensive than the piece of equipment on the transformer. And depending on your history with the equipment, whether it be ours or anybody's, you could implement a replacement cycle just based on your history with the equipment, your knowledge of the equipment, and what you've experienced in your area. So it's very, very dependent on environment and climate and conditions. So what we can do to help with replacements or emergency replacements are universal solutions. So we have a couple different universal options, mainly in our remote temperature gauges and our liquid level gauges. So with our universal remote temperature gauge, which you can see on the right here, it features a universal probe length and diameter, includes thread adapters for unknown well dimensions and well threads. It includes both a liquid and winding temperature faceplate, and these can be customized actually. So if you need a different dial range or only want one faceplate, we can do a full configuration on that and still give the universal probe and thread adapter option. So you can actually, if you wanted to, you could stock some of these for emergency situations or for really old gauges that you don't know what they were, and it's harder to go get the specs for that to get an actual replacement, and this will work just fine. So what we can do with this is this probe will go in. It has sleeve adapters for diameter, and then it's an adjustable length. So it can fit any length well, and then this can be bent down out of the way and installed like a normal probe. As far as our universal liquid level gauges go, we have them for both the 6-inch and the 3.5-inch style liquid level gauges. They feature adjustable switches and adjustable high 25C and low indication points with these little flag indicators here. And these will work with any liquid level gauge flange that was a Qualitrol. So the back end, the flange portion, which comes back to testing the liquid level gauges, the case is usually the part that needs to be replaced, and the flange is typically okay. Especially when it spends all of its life submerged in oil, there's not a lot of wear on that. Most of them it's either a lever design or a gear design, and they're pretty reliable and robust. So most of the time the case, which is out in the environment and the conditions, needs to be replaced. And that's where these universal options will work with any Qualitrol flange from any era, for the most part. And it's a quick and easy way to get a replacement in a pinch if you need to, and you can't go through the speccing process. So like I said, they're perfect for unknown gauges and emergency stock. And also for replacements, we can do, sometimes it's just a connector that's gone bad. And our connectors have been the same for a very long time, and we can replace those really easily. And then lenses, sometimes older lenses that have been, say, in a desert for 40 years is a little fogged up. Most of our old gauges, we can just replace the lens and keep it going if the rest of the functionality is still there. So as far as custom solutions and what we have to offer, so we have a team of design engineers here at our headquarters in Fairport, where we can help recreate any old or obsolete design. So like an old pressure relief device that we don't know the manufacturer, but we can get the dimensions off of, we can replace that. Old obsolete test and temperature gauges or old winding temperature indicators, things like that. And obsolete Westinghouse sudden pressure relays. We have a quick replacement for that with the newer rapid pressurized relay. And we have a number of adapter plates already made up for a lot of this old and obsolete equipment. But if we did need to go for a completely new design, our lead time on custom gauges is typically only 3 to 4 weeks. And like I said, many of the adapters are already available. This is a big replacement. A lot of these old Westinghouse sudden pressure relays are getting old, and it's a quick replacement for the rapid pressurized relay. So to help out with custom solutions and universal solutions, we have a full support team, a few locations actually. So we have a team of application engineers here at our headquarters in Fairport, and they can be reached every day directly by phone. You can call in and talk to an application engineer. Our phone number is right there, and that's Monday to Friday, 8 to 5. We also have customer service support centers in Europe and Asia. And our application engineers are really a great resource for finding those old gauges that you need or answering technical support questions. And a lot of these testing tips and tricks have come from feedback from our application engineers saying, you know, we get a lot of questions on this, maybe it would be a good idea. And then we also have a direct support via our web chat on our website or by email at info@qualitrolcorp.com. And you can see Matt and Will here. This is a little snip of the web chat and what it looks like. They're both based out of right here at our headquarters in Fairport, and you can chat with them direct and get an answer real quick. So lastly, we're going to talk about a couple upgrade opportunities. If you're on site, you find a bunch of failures and it's a critical transformer, and you would like to gather a little bit more information than you currently have, you can think about monitoring. So this will be a high-level look at the monitoring solution we offer for replacing a lot of these old electromechanical gauges for something a bit more advanced. So first here we have our Qualitrol ITM 509. It's an intelligent transformer monitor. And this can bring in all of the same signals that you would currently have on your transformer with just switch functions. So top oil, winding temperature, you can take in your liquid level, your pressure, and all of those, and you can bring them into one central location and communicate that out. So that's a great upgrade for a critical transformer or an aging asset where it could be a potential hazard or anything like that, where you're currently only getting an alarm contact or not getting any contact or not getting any remote communication at all. The 509 can bring in all of that information and communicate that out over numerous different protocols and communication styles. It has a built-in loss of life calculation, which is standard on every unit. We can do it in a panel mount or a control cabinet, for a panel mount in the control cabinet, or a standalone enclosure, which is really good for retrofits. It's fully configurable, and it has a configuration software for setting relays, accessing data logs, and things like that. Another upgrade that you could consider with monitoring is our Qualitrol 930. This would replace the traditional rapid pressurized relay or sudden pressurized relay with a more advanced solution. For example, the features this have is, one of the big ones is 2 out of 3 logic for sudden pressure indication, and also adjustable sensitivity. So what the 2 out of 3 logic does is that it makes sure that it needs to sense 2 or more sudden pressure occurrences in the tank to actually trip or alarm. This is done using 3 pressure transducers on the tank. They can be in 1 location or 3 locations, and they have adjustable sensitivity to ensure accurate sudden pressure trips and eliminate nuisance trips. So if you have an older unit with very high vibration or in a seismic zone, this would be a great option for that. And along with just doing sudden pressure indication, it also has static pressure indication, so constant tank pressure over 4 to 20 that can come out. And then it also has the built-in seal and relay function. So it kind of brings everything into one and gives you more information with a more accurate sudden pressure indication. And then we have a similar test kit available for this, just like the rapid pressurized relay, but for this monitor.
Again, thanks everybody. Thank you, Phil, and everybody have a great day.